Welcome back to Advent of Code 2023, Day 9. Hello, Amara. Easy for a Saturday. Haven't finished yet, though. Okay. So that's interesting. It's been a string of somewhat easy problems recently. I mean, compared with the earlier section of the month. All right, let me just get my coffee. Actually, I'll put the screen on. Right, Mirage maintenance. Alright, you ride the camel through the sandstorm. Oh yeah, because we were getting lost in the desert last time. And stop where the ghost's maps told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one made of metal. This whole land is starting to feel like the Super Mario RPG world. Just a bunch of islands with different climates. This must be where the parts to fix the sand machines come from. There's even a hang glider. Right, Wikipedia for hang glider. Got to get those views in. The Wikipedia people have got to see the traffic randomly spike on all these pages for no reason. Partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. Thermals. While you wait for the sun to rise, you admire the oasis hidden here in the middle of the desert island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Each line in the report contains the history of a single value. For example, 0, 3, 6, 9, 12, 15. Okay. It's an arithmetic sequence. Is it? Well, the second line is triangular numbers, isn't it? To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Okay. I see. So... Wait, so the first line Oh no, so this is the fixed input. All right. The sequence of differences is 3333. Okay. So since these values aren't all 0, repeat the process. Oh, we're taking one line and we're acting on it. Okay. So we take the next set of differences. So this is the set of differences, and then we take the next set of differences to get 0, 0, 0. Okay. Okay. Some of those steps aren't really needed. Which steps? Seems like we need all the steps, don't we? To confirm that it's all zeros. The zeros and all. Just have to predict the next number. Okay, I guess I need to read further because there's more here. To extrapolate, start by adding a new 0 to the end of your list of zeros. Okay. And then you work backwards, I see. So A has got to be... The result of is now basically the addition of that 3 and 0. So it's 3. 15 will be 18. 15 will be followed by 18. Okay, fine. Alright, in the case of the second line, we go 2, 3, 4, 5, 6, 1, 1, 1, 1, 1, 0, 0, 0. Then we go 0, 1, 7, 28. Okay. If you find the next value for each history in this example and add them together, you get 114. And these are the sequences. Okay. Just follow these steps then, I guess. Right. But I don't see what you mean by skipping steps. Wouldn't you still need to... Like, you don't need the 0. Well, yeah, I mean, you need to output just the number on the top row. I get that. But you would actually need to calculate these. All right. Okay. As soon as the numbers are all the same, you're done. Oh, I see what you mean. Okay. That's, yeah, I guess micro optimization. Just one line saved. I'll just do it the way they've. I'll go for the full zeros. Just it doesn't look like we'll save much time anyway. Let's try fetching the input from URL just to change things up a bit. How do I do this? Put URL lib. How do I use this? URL lib dot. All right, just Google this. Okay. This isn't, well, okay, this is probably, try this. Isn't there an AOC import? What do you mean? Like an actual Python library? It's probably overkill though. I think we can just Alright, this is an old post. I don't think it works anymore. This just Alright, let's Hello, Olympus Tiger. I think I came across one, but I haven't tried it. I've seen some Python solutions with import AOC or something like that. Maybe someone's made a library that you can just download. All right, let me do this way. All right, and then so Olympus Tiger, are you participating in this year's Abundant Code? All right, so the URL is going to be response equals requests.get URL. First year. As in you were doing the first year of the batch, 2015? Oh, no. You mean this year is the first year you're participating. That's nice. I think every year we are getting a lot more people. It's growing in popularity. It's good. I mean, Eric's shown that he's committed, unlike certain other companies that are shutting down their programming competition. Google. All right. And then what do we do with that? Let me have a look, see if that actually... can we split it into... Okay, we want to do print response dot... Can we get lines, or do we need text dot split back in? Oh yeah, of course. You need to be logged in. This is not gonna work. That's why you need an AOC library. All right, don't worry about this. I might look into it for next time. It's not exactly going to save much time, but it's kind of cool. All right, I'll paste it in by hand. Yeah, of course you need to be logged in. But I do like the idea of my program being completely offline. So I don't know, maybe I'll just stick with this, but all right, so for a given sequence, so what ultimately we just want to compute a total. Alright, let me just have a look. You could use selenium. Yeah, you could. I don't want to mess around with cookies and logins and stuff, but it's probably not that hard. But yeah. All right, a new person has joined my leaderboard. Every day of your life counts. Who's this? All right, anyway, I'm getting distracted. We want the sum. Okay, just plain old sum. Okay, so I guess just... All right, we'll just put the input in lines because we're going to need it for part 2 anyway. So sequences equals that for line in f.readlines sequences dot append list map int line dot strip dot split. Okay, that's all the parsing we need to do. Nice easy parsing this time. All right, so okay, so can I zoom in a bit? How do I zoom in? It's Alt Shift dot. There we go. All right, so now let's make a method which is going to... Did the music go much quieter all of a sudden? Yeah, that's fine. A method which is going to take a time get next term of a sequence. So that takes a list of ints and gives the next int of the sequence. All right. So I guess we're going to create this sort of matrix here. rows equals, let's just say just a list where this sequence is the first row. So while not, can we start with all zeros? Have they thrown that at us? No, they haven't, but I mean, anyway, we should probably handle that case. Anyway, while not all x is 0 for x in the final row, we need to create a new row. So rows dot append. I'm a bit hungover today. That's also why I started very late. Rows dot append. Put an empty row there, and then for I in range, I used recursion, but I guess it's not needed. Yeah, I mean, it would work. In this case, because we know there's it's exactly one layer that we need to process each time, is probably more efficient to avoid recursion. Then we're doing the exact amount of work needed and no... Well, it's not like these rows are too big anyway, but no extra stack usage. Alright, so for I in range length of rows -1. Yeah. No. Row, so it's going to be final row. Actually, okay, first, let's not put this empty list in yet. Let's just say new row equals this. All right, because otherwise it's a bit confusing. Okay. And that's wrong. It should actually be last row. All right, so we want new row dot append. So it's going to be rows -1 I +1 minus rows -1 I. So that's the difference between this term and the next. Okay. And then we need to put that in the, so rows dot append new row. So that there. Okay, so that will go until we got all zeros. And then we just work backwards through the rows. So, okay, so rows, so the final row, just put a 0 there. And then for I in range, just go starting with length of rows, -2, finishing 0, going backwards. We're gonna take rows. So rows I is the one we want to add an element to now. So we're gonna append. So it's gonna be rows I. So whatever's at the end of this row plus rows I plus 1, the next row, and whatever's at the end of this row. I think for those that are unfamiliar with Python's indexing, this probably looks like a horrible mess. I mean, I would normally write this in a cleaner way using, I don't know, some more object orientation. Alright, so, and then we should just end up with the element in the first row, shouldn't we? So return rows, first element, the first row, last element. Okay. So we want total equals sum. I'm just gonna trust this works, and we'll see. Sum of get next term row for row in, let's say, sequences for sequence in sequences. All right, let's just see if it works first time. Nice big number. So these numbers are going to grow. Yeah, that looks like the right size. Yeah, I mean, these are big numbers. And they'll grow. Well, they won't grow that much because we're only adding one element. But yeah, okay. Believable. Correct. Right. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0. Then, rather than adding a 0 to the end and filling in the next values of your previous sequence, you should instead add a 0 to the beginning of your sequence and fill in the new first values for each previous sequence. Is that it? So by symmetry, you're basically doing the same thing, or am I missing something obvious here? Easy. It is easy, isn't it? The only thing which is not going to be a problem for these input sizes is that in Python, if you insert at the front of a list, that's inefficient time. So ideally, we would want to reverse everything now and wait, would that work? If we just reverse all the rows, would that just give us the answer if we reverse all the rows? So if this was, I think it would, wouldn't it? So I could well, we could try it. if I've reasoned this out in my head correctly, then literally all we need to do is just reverse every row. Don't need to put stuff at the front. So here we would want sum of get next term sequence. So literally just put this in colon colon -1. $1019. Does that seem right? Yeah, because there's going to be small numbers. Could this be the single easiest part 2 we've ever had? I added 1, 2, 3, 4, 5, 6 characters. Well, okay, I copied and pasted lines. No, well, no, I could have changed part 1 by 6 characters, so... Yeah, you can just reverse every row. It might be the easiest day after day 1, barely. So, what did I say before the easiest day was for me? It was the boat race. I would say the boat race is still conceptually easier, but this one was a very easy one to code. But this one, I can see people maybe tripping up with indices and stuff. Like I could have, but yeah, this is pretty easy. Hello, Azulverdo, but the difference is not the same. But the difference is not the same? Sorry, what do you mean by that? Right, so I'm expecting a very fast top times for this. 1 minute 48? Yeah, that sounds about right. 1 minute 16. So for example, Oliver Nee took 1 minute 28 to do part 1. And then a further 20 seconds to do part 2. I could have done part 2 faster than that. No, it took me more than 20 seconds to read part 2 at least, so not really. They might have been stumped for a few seconds thinking, no, this can't be that easy for part 2. I mean, I was about to just copy and paste the whole method, but change things to putting at the front. But yeah, it's overkill. You could just reverse the rows. Tina Wong, student. Okay, noted. You're a student. All right. Well, nice easy day. Which is good because I'm hungover today, so I needed something easy. I use while and pairwise until zeros and just summed the last item of its row. Is that roughly what I did? I'm not sure what you're describing. So this is the my stream leaderboard. I can post, in case anyone wants to join, I'll post the code here. Basically, yes. Okay, yeah. Yeah, I mean, you basically just follow... I think a lot of these days, he's quite accurately describing the algorithm you need in the actual description. A lot of the time, if you just follow what is said in the description step by step, you don't need to think of some, like, in past, well, we haven't had many, for example, breadth first search algorithms where, you know, he kind of indicates you need to search, but he doesn't tell you how. But that might come up in later days. But yeah, a lot of cases here, the description, you just do it as described in the description, even for part 2, which is generous, but it may not hold for long. At some point, we're going to get assembly code problems. I'm sure of it. Everyone dreads the assembly code problems. And since Olympus Tiger, you said this is your first year, I don't know if you've seen the assembly code problems, but they're very cleverly written problems, and Eric likes to use them, but they're quite tough, and they are not even easily solvable just pure from code. Sometimes you need to do some investigative programming, like you need to understand the semantic nature of the code that he's given you and what it's doing, and like figure out how to alter it to stop it from looping and stuff. It's quite hard in general, because it's not just write a program to do this. You've actually got to do a bit of original kind of a lot of people don't like the assembly code problems. I don't blame them. I think they're pretty smart. They're pretty clever. But in the last year I did, which was an archived one, 2018, there were a lot of assembly code problems, and the later ones actually built on the previous ones, so you needed to have solved the previous ones really to be able to do those. They weren't independent. There were maybe 3 or 4 days, so it was a bit much, I think, but I think he probably took notes of feedback. I won't have as many, as much assembly code. I think 16 was one. Yeah, this is an assembly code. So, it's not complex conceptually, it's just the actual input you get. What's this? Okay, in this case, you weren't given an actual assembly code script. You were given inputs and outputs, and then you needed to sort of alter the code in between. So this was even harder. But basically, assembly code is like machine code. You can add numbers to a register, you can store numbers, you can multiply them, you can bitwise. I think they're very cleverly written problems. You don't see many problems like this out there, but they are hard. Hello, Smab UK. I used 2018 for practice. I just got to 16 as practice when December arrived. Oh, yeah. And 16 is not the last assembly code, yeah. And then there's something which uses 16, so you kind of need to do 16 to continue, or at least fully understand 16. You don't need to solve it, but you need to have coded all these instructions, ideally. Got the first star. What was the next one? So it was probably one of the very final days. No, it wasn't that late. When I won't be able to continue this year's, I'll start the last year's. Well, I mean, the difficulty kind of goes up and down, so you can skip days, because sometimes even later on, you'll have some easier days. I mean, the final day, Christmas Day, is usually not too hard because, you know, Eric doesn't want to deprive us from our families, just spend the whole of Christmas Day at working on a problem. So, shocked at how trivial today was for day 9. Yeah, today's was a very easy problem. It is a weekend. People have said that they get easier at the weekends. I've not really paid attention to that, but maybe. I don't know why. You'd have thought it'd be the other way around. Like, might as well give us a hard problem at the weekend when we have time to actually sit down and solve it. And easier problems on the working days. Yeah. Also, the final day, 25, it's always the same. There's only a part 1. And then part 2 is literally just, you get part 2 for free if you've got every star for every previous day. So people can spend time with their families. Oh, yeah, I guess some people do that at weekends. But yeah, so yeah, the part 2 for the final day is usually it's just a part 1, and it's usually not too hard. So yeah, after this month is over, I'll give it a couple of months, and then I'll try and do 2019 and 2021 as well. Then I'll be a 100, 200, 300, 400, 450 star holder. That's the dream. So, looking at yeah, look, there's a high part 2 completion. There's always some who just don't do part 2, but that's as high as the percentage really gets. Alright, well, yeah, nice easy day. Now I gotta get the YouTube video up because it's pretty late. People are probably just refreshing YouTube waiting for my video. I think too highly of myself. Alright. And I may well have a go at Doom later for the Wheel of Struggle. I gotta set up all that stuff. Because I gotta set up GZ Doom. And we've got quite a specific set of rules for what things you're allowed and what things you're not. You're not allowed to jump or crouch, because GZ Doom adds those things to the engine. All your fans. The YouTube videos I've been uploading have actually been quite surprisingly popular. I guess day 1 has had about 2,000 views. So yeah, I was surprised, but I guess as Advent of Code grows in popularity, naturally there's more people searching for a walkthrough of these problems, and as long as someone's doing a whole series of them. Hello, Aeon Lol. Day 5 really bummed me for a while, and your vids really helped me understand. Well, there we go. Somebody has found me through my videos. I suspect some others have as well in chat. Well, thanks for that, Aeon Lol. Day 5, which was that? Yeah, this I think was this considered to be the hardest one? So day 4 was scratch cards. Some people tripped up on this one. I was like, yeah, I think day 5 was the one where you really had to be a bit smart. Some people managed to brute force this, but working backwards from the locations. So they just went through the locations, location 0, location 1, location 2, and then just went back through the maps. But they got lucky with the inputs, because other people who tried that couldn't, because the inputs were too large, like it was in the billions. So brute force, I think, can work if you're lucky with the inputs. If you're unlucky with inputs, you might need to do a sort of simulated annealing. So just randomly start and stop at different positions or something. I don't know. Recognized your name from a leaderboard when I was looking for streamers working on AOC. A leaderboard. Oh, well, I joined one guy's leaderboard. That could be. Is it Captain Coda? I was watching him on Twitch. He was using C Sharp, was it? Ah, yeah, you're there. I think I only watched one stream, but yeah, I'll try and catch Captain Coda's streams because he normally does it quite a bit later after the problem releases, doesn't it? So how many years have you been doing Python, brother? Oh God. I think 2011 was when I first discovered Python, and I was like, whoa, this is so much better than C, which is what I was trying to use for my coursework, for my maths degree. So yeah, just over a decade. Actually, that doesn't seem like that long. Um, I felt like it was longer, but yeah, just about 12 years. Um, yeah, because in my maths degree, we had a piece of computational coursework where we had to use code to, I don't know, do some statistics or do some graph theory algorithms and stuff. And we were struggling with C, and then I decided to switch to Python because C was recommended by the university because they gave us some documents and resources for it. Most of my classmates stuck with C and they suffered. They suffered for months. And I switched to Python, and a lot of the mathsy stuff you can just breeze through with Python. It's so much easier. So, oh, Captain Code has started streaming. All right, well, I might raid him then somehow. How was I supposed to know LCM would work for that? Uh, it's just one of those things that comes up in these types of problems a lot. Well, I don't know about advent of code, but lowest common multiple, a lot of number theory problems revolve around that. So it's just greatest common divisor and lowest common multiple. So greatest common divisor is, some people say it's the oldest algorithm ever made, the oldest proper algorithm that's actually documented in history. The Euclidean algorithm for finding the GCD. So it's a very traditional algorithm, but yeah, you can do a lot of stuff with prime numbers, prime finding, finding common factors. Then you got encryption. At least encryption based on like prime numbers and stuff. So RSA algorithms uses stuff similar to GCD and stuff. So yeah, it's a good thing to just be familiar with LCM and GCD. What is your major? Mathematics was my undergrad, and then I went on to do computer science, theoretical computer science for postgraduate. 95% of the languages that people use to solve this didn't exist yet. Yeah. Yeah, the language scene has definitely changed a lot. Let me try and find what is the username for Captain Coda? There are Captain Coda, got it.
You can also do a loop. There's nothing wrong with doing it as a loop. Recursion might.
All right. Well, thanks everyone for stopping by. It seems like I had quite a large turnout today. I got to sort out the YouTube videos, so I'll pass you on to Captain Coda, and I'm interested to see what he does. He looks like he's I don't know how far into it he is. All right, well, let's go check him out then. And I'll see you tomorrow. I'll try and start earlier tomorrow. I won't be as hungover, hopefully. All right, bye-bye.